All right, we're on lesson 4, which is on percent change. So to start, we have an opening exercise just to kind of get ourselves in the mindset of what percent change actually means. So it says Cassandra likes jewelry. She has 5 rings in her jewelry box. In the box below, sketch Cassandra's 5 rings. All right, actually, I might have a ring sticker. Hold on, because that'd be cool. Maybe not. Good. All right, so we are going to sketch those rings. So it doesn't have to be anything crazy. There's 1 ring, 2, and 5. All right, so those are her 5 rings. Now it says draw a double number line diagram relating the number of rings as a percent of the whole set of rings. So double number line, we're going to start with 1 full line on the side. That means there are 2 lines coming off of it. Okay. We're always going to start at 0, so our first dash is going to be 0. Then we're going to break it down all the way up to 100. For the bottom, we'll put the percent. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And try to make sure those dashes are right on top of the other ones. So our percent is going to be on the bottom, and the rings will be on the top. So if Cassandra has 0 rings, then she has 0% of the rings. If Cassandra has 1 ring, 2, 3, 4, 5, we're going to break down these percentages based on each ring. So 5 out of 5 would be 100%. And each time we lose a ring, we're going to go down by 20%. So 80%, 60%, 40%, and 20%. So the percent that represents the whole collection of rings would be 100%, because 5 out of 5 rings is 100%. Then it says, what percent of the collection does each ring represent? Well, 1 out of the 5 rings is 20%. Each time we add a ring, we get 20%. So we're going to look at what happens when Cassandra gets another ring. So it says, Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will the percent increase in her ring collection be? All right, so if Cassandra buys another ring, okay, this percent increase means that it's going to go up by the 1 ring. But we want the answer as a percentage. So let's see. When we take a look, if she has 5 out of 5 rings, that would be 100%. But now she's going to have 6 out of her original amount. 6 out of 5. When we take a look at percents with new amounts and original amounts, our original amount is going to be our original amount is going to be the whole, and our new amount is going to be the part. So when we set up our little cheat sheet off to the side, I like to write down and label that the part means the new amount and the whole means the original, or the OG. So let's write our formula. Part equals percent times whole. So the new amount is 6 rings. her percent is what we're trying to find, and the original amount which she started with is 5. So we're going to plug that in. 6 equals x times 5, and divide by 5 on both sides. So 6 divided by 5 is going to give us 1.2. But remember, we're finding a percent, so that's only our first step. Second step, we have to change 1.2 to a percent by multiplying by 100. So now we have 120%. But when it asks us for a percent increase, we only want how much overflow there is. What I mean by that is how much over 100% it is. So I'm going to take 120% and subtract 100%. So my percent increase is 20%. This should make sense based on what we talked about. One ring represents 20%. So if she gains one more ring, the percent increase would be 20%. So let's try this on another problem. So it says John increased his trading card collection by 5 cards. He originally had 15 cards. What is the percent increase? So he increased the trading card collection by 5. So if he increases it, I have to add. And he originally had 15. What is the percent increase? Okay. So the first thing I need to do is figure out what my part is, or my new value. Well, if he increases his collection by 5, if he started with 15, I'm just going to add the 5. His new amount is 20. So that's my part. So let's write our formula. Show our work for our cheat sheet. Part is new. Whole is the OG. All right, so my part is 20. I'm finding the percent, so that's x, and the whole is 15. Let's plug it in. 20 equals x times 15. Divide by 15 on both sides to get x by itself. 20 divided by 15, it's going to be a repeating decimal, that's okay. 1.3 repeating. Now, since we're finding percent increase, remember we have 2 more steps here. This is the first step. Second step, I'm going to change this to a percent. Now, we just have to be careful since it's a repeating decimal. When we change this to a percent, by multiplying by 100 or using the buttons in our calculator, when we write a repeating decimal as a percentage, we need to make sure we have the repeating sign after the decimal place. So it should look like that, 133.3 repeating. Now, I just want the increase, so I'm going to subtract. So 133.3 repeating minus 100. I'm going to have 33.3 repeating percent. So that's the percent increase. All right, let's try another one. Suppose instead of increasing the collection by 5 cards, John increases his 15 card collection by just 1 card. Will the percent increase be the same as when Cassandra's ring collection increased by 1? Why or why not? Explain. All right, so let's solve this first. So remember, we are increasing our amount by 1 card. So we have 15 plus 1 this time, so our part is going to be 16. And it's still a 15 card collection, and we want the percent increase. So part equals 16. That's my new value, or new amount of cards. I'm finding the percent. And the whole is my original amount of 15 cards. So let's plug it in to our formula. 16 equals x times 15. And let's divide by 15 on both sides. 16 divided by 15 is going to give us 1.06 repeating. We have to change that to a percent, multiply by 100 or use the calculator with the second button and the percent key. So we have 106.6 repeating percent. And last, we're going to subtract. So 106.6 minus 100. So we've got 6.6 repeating percent. Now this is different from Cassandra's ring collection. So the answer to the question would be no, because they started with different wholes or original amounts. So the value you have for your original determines everything else that you're going to get. So we have to be very careful how we're setting up the problem based on that amount. Okay? All right, let's go to the next page. So now instead of percent increase, we're going to look at percent decrease. So all that is instead of the values increasing, they're going to go down. So it says David moved from a house that is 89 miles away from his workplace to a house that is 51 miles away from his workplace. What is the percent decrease in the distance from his home to his workplace? All right, so remember, we'll just put a little note at the top. Part equals the new amount, and whole equals the original amount. So he started with a house that was 89 miles away. That's going to be the whole. And now he's only 51 miles away. That's the new amount, so that's the part. We want percent decrease. So let's write our formula. Part equals percent times whole. And set up our cheat sheet. What? Okay. Percent. Part is the new. Whole is the original. And we've got 51 and 89 and x for our percent. So let's plug them in. 51 equals x times 89. Opposite of multiplication is division, so divide by 89 on both sides to isolate the variable. 51 divided by 89. We're going to get a very long decimal. We're going to write the whole thing. 0.5730. 3708. So that's the whole thing that's on the calculator equals x. All right, now we have to change that to a percent. So we're still doing the same steps. So first step is solving for the decimal. Second step is changing it to a percent. So multiply by 100 or use the buttons in your calculator. 57.3. And we're still writing the whole thing that showed up on the calculator. And my last step is to subtract from 100. So since this value is smaller than 100, we're going to subtract from 100. So it should always be highest minus lowest for this. So 100 minus 57.303. Percent. which is going to give us a wonderful percentage of 42 and a long decimal, 0.6966292%. I ran out of room. All right, but same exact steps. That one just happened to be a very not fun decimal. So I'd like you to pause the video and try the next one on your own. So it says the price of a pair of shoes decreases from $60 to $50. What is the percent of change? So pause the video and try it on your own. When you're all set, unpause the video and check your work. All right, so we are finding the percent of change and it decreases. We start at $60 and go down to $50. So our part should be 50. Our percent is what we are finding. And our original amount is 60. So part equals percent times whole. 50 equals x times 60. And divide by 60 on both sides to get your answer. 50 divided by 60 is going to give us a repeating decimal again, but this one's a little bit nicer. It's 0.83 repeating. Change that value to a percent. It should have a decimal with a repeating symbol. And then we're going to take that value and subtract it from 100. So 100 minus 83.3 repeating percent. Just going to give us 16.6 repeating percent. All right, that is all for this lesson. Good luck on your homework.